All right, guys, we're on to the next page. This is pumpkin dropping. So this is something they actually do at Old Dominion University, ODU for you NCAA basketball fans. Um, and so let's just read through here. It says at ODU, physics students have their own flying pumpkin contest. Hopefully, the sub played the video on the previous page where they showed them actually doing this. It says each year they see who can drop pumpkins on a target from 10 stories up in a tall building while listening to music played by the Smashing Pumpkins. You guys don't know who the Smashing Pumpkins are. They're awesome. Check them out. By timing the flight of falling pumpkins, the students can test scientific discoveries made by Galileo nearly 400 years ago. Years ago. Galileo used clever experiments to discover that gravity exerts force on any free-falling object so that d, the distance fallen, will be related to time, t, by the function d equals 16t. So distance equals 16 times the time squared, okay? So whatever the number of seconds is, we square it and multiply it by 16, and that's how far it's fallen. So for example, suppose that students dropped a pumpkin from a point that is 100 feet above the ground. At a time 0.7 seconds after being dropped, the pumpkin will have fallen 16 times 0.7 squared, so about 7.84 feet, leaving it 92.16 feet above the ground. So let's just, on this model here, okay? So what they said that this distance was about 7. What did they say it was? 7.84, okay? So what they did is they plugged into that equation, all right, where distance was 16, and then they multiplied that 0.7. Well, they squared it, okay? So they squared 0.7 and multiplied it times 16, and they got 7.84, and so that goes in here. That's how far the pumpkin has fallen after 0.7 seconds. And now all they do is they subtract 100 minus 7.84 to figure out what's left. That's this height right here, okay? So what's left, they said, is 92.16. 92.16. So it's important that we can visualize that and understand how they come up with that, because we're going to do a bunch with equations with this thing, okay? And so also you guys might be thinking, well, what about wind and all that kind of stuff? Well, the model ignores other things like air pressure, but it says here, heavy compact objects, this function pretty accurately describes how they fall. Okay, now create a table like the one below to show estimates for the pumpkin's distance fallen at a height above ground in feet at various times between 0 and 3 seconds. Okay, so what I want you guys to do, so go ahead and do that. Now notice here, okay, so I'm going to show you how they did the first one here. So they said, well, distance equals 16 times 4 squared. I take that back. They did times 0.5 squared, okay? So what they came up with then is distance equals 16. Now 0.5 squared, you're going to find out, is 0.25, okay? And so 16 times 0.25, distance equals 4. So all you have to do is just plug this number into your calculator, okay, in place of this equation, all right? And then your distance, you're going to write in here, okay? So you're going to do the whole thing. I'll give you a hint. So this next one is going to be 16 times 1 squared, but 1 squared is just 1, so this is going to be 16, okay? Now we go over here, we do 100 minus 16, and I get 84. So do that whole thing for the rest of this table, and then maybe the sub could have different people come up and put their answers on the board. All right, so that's the first page. Ready, set, go.